The Zeer Pot or pot-in-pot refrigerator is a clay pot cooler that uses evaporative cooling, allowing for electricity-free refrigeration. Water is able to evaporate out of the sand and out of the outer clay pot, which removes energy from the system. This is possible because the pot used is of a porous material, making the system an open system. Since the system is in steady-state conditions, a loss of heat energy is likely a result of a decrease in internal energy of the system. The Zeer Pot is most useful in dry, hot climates with low humidity and will not be very effective in humid regions. This is because the water in the sand is diffusing out of the system into the surroundings. Water diffuses in a concentration gradient from high to low concentration. If the humidity of surroundings has a concentration close to that of the system, evaporating cooling will occur slowly. If the humidity of surroundings has a greater concentration of water, then the evaporative cooling would not occur. Rather, the sand-water mixture would increase in water concentration due to diffusion.
As per every thermal class, there's always time for a quick joke. The things you will need for this experiment are a large pot, a small pot, sand, plumber's putty, a small bowl, a thermometer, fabric, and water. First, fill any holes in the pots with plumber's putty. Place the smaller pot into the larger pot and fill the gap with sand. Saturate the sand with water. Then place some water into the small bowl and place it into the pots. Then place the thermometer in the bowl of water. Dampen the fabric and place it on top of the pots and check on the temperature every 30 minutes. Our experiments will explore the evaporated effects in a humid climate and a dry climate. Let's see how our pots will do. Our first location is Miami, where the forecasted relative humidity for that day was 87%. This is a quick time-lapse of the results we obtained. As you can see, the temperature of the water inside the pot increased as the outdoor temperature increased. These results will be discussed later on.
Our next location is Philadelphia, where the average relative humidity in December is 64.1%. The relative humidity in the room was measured during the experiment and ranged between 92% and 74%. The room temperature had a high of 60 degrees and a low of 58 degrees, while the pot temperature ranged from 50 to 54 degrees Fahrenheit.
In order to understand how the Zeer Pot works and why our results turned out the way they did, we have to understand relative humidity. We can gain an understanding of relative humidity by using Raoult's law. First, let's try to figure out what the maximum amount of water that the air can hold is. So starting with Raoult's law, we know that the vapor pressure of water at 25 degrees Celsius is 0.03 atmosphere. Next, we can assume that the liquid mole fraction of water is 1, and also that we're at atmospheric pressure or 1 atmosphere. From this, we can clearly see that Y water max is 0.03. And this is the maximum amount of water vapor that could be in the air. If the actual amount of water vapor in the air is 0.015, then our relative humidity comes out to 50%. So now let's apply our understanding of relative humidity to the function of the Zeer Pot. In a drier climate versus a less dry climate, so for example, if we're considering two locations that are both at 25 degrees Celsius and 1 atmosphere, and one has a lower humidity than the other, the air in the drier location is not holding the maximum amount of water vapor that it possibly could. Therefore, in such a climate, a drier climate, this would allow more water vapor to evaporate from the Zeer Pot, which causes more of a cooling effect because the more water that leaves, the more heat is absorbed from the Zeer Pot and its contents in order to evaporate. Lowering temperature can also change how much water vapor is held in the air. As temperature decreases, vapor pressure also decreases, and as a result, the maximum humidity decreases as well, because Y water max is directly related to the vapor pressure of water at the given temperature. As a result, the Zeer Pot would not work as well in cold climates because the max humidity is lower and not as much water vapor can evaporate into the surroundings. Therefore, based on Raoult's law and the effect of temperature on vapor pressure, the best place to use a Zeer Pot is a hot and very dry climate. Unfortunately, neither experimental condition was both hot and dry. Therefore, the Zeer Pot did not work super great in either experiment. However, it worked better in experiment 2 because it is much drier in Philadelphia than it is in Miami. And it was really interesting to see how well the Zeer Pot worked in a relative humidity of lower than 80%. The contents were cooled by about 8 degrees on those days, even though the temperature in the room was the same in all of the days. The results from experiment 2 can be directly explained by Raoult's law and the concept of relative humidity. Overall, it's okay that the Zeer Pot didn't work well in either condition because according to our knowledge of Thermo 2, it's not really supposed to. But maybe if you're in a really, really heated NYC apartment in the winter, you'll be able to use a Zeer Pot there.